Everyone, page 34, other than Kayla. Page 34. Kara, are you there? Page 34. Are you there, Zodi? Raven? Amira? Henshaw? What, Margaret? Chase? Alini? Abbott? Same one we were on yesterday, just scroll down. Kayla, did you find your old username and password that I had sent to you, or had you set up a new password? Okay, what did I send you an email that had the new username and password? Okay, well I'm sure it's there unless you deleted it. Just search my name. You might have to use the guest. Okay, let's get going. Hello to everybody that we're recording for. Example B on page 34. That's what we're doing. Okay, Zodi, can you help me out so I don't have to just keep looking back at my book? What we want to do, just give me the pre-image coordinates. I'll write them down here. And it looks like it's P, Q, and R. And then we'll get the other ones. All right, so what's the coordinates for P?
-3, -1.
-3, -1. Q?
3, -1.
3, -1. And R?
1, -4.
1, -4. Okay, and those are mapped to the image. It kind of seems backwards that we start with a pre-image and go to an image, but how we do it? P prime, Q prime, and R prime. And what's the coordinates, Zodi, for P prime?
-3, 1.
-3, 1. And for Q prime?
3, 1.
3, 1. And for R prime?
1, 4.
1, 4. Okay, so here's the question. When we do remember this is the second type of problem where we know the picture and we're trying to find the rule. Okay, we don't have the rule. You want to look for a pattern. Okay, so we want to look for a pattern. Do you see one? First of all, compare the x coordinates. If I look at the x coordinates, do you see a pattern between the pre-image and the image? Do you notice anything? What do you notice?
They stay the same.
They stay the same. I agree. So if I'm going to write the rule, I'm going to write it like this. So I know that the rule, xy coordinate, maps to, there's no change. And so this stays as an x. Now, what about the y's? Do you see a pattern on the y's? What do you see, Raven?
There's no negative.
That's right. And so to go from this one to this one, there's no negative. What would we have to do mathematically? What operation?
You would have to make a negative y
How?
by multiplying by -1.
Ah, you got there. Great. We need to multiply by -1. -1 times -1 is +1. -1 times -1 is +1. -4 times -1 is +4. And so she was exactly right that you multiply the y by a -1. Yesterday we did one like this where we multiplied the x by a -1. Do you remember this? Do you remember what happened when it multiplied by a -1? What's that called when you pancake it?
Reflection.
Reflection. Do you remember my wonderful illustration yesterday? Hold on. Gotta erase it. Remember? Didn't I do that for you guys yesterday? Okay. And then when we multiply by a -1, what happens? It reflects. If we multiply the y by a negative, it reflects across the x. So it goes this way. All right? If we multiply the x by a -1, it reflects across the y. Okay? It's like a pancake or an omelet. What else do you flip? cheeseburger. All right. Questions on example B? Now, that's the rule. So really, that's all you need. Now, if you look in the book, it actually does the distance formula, but that's just to determine whether or not they are rigid. Right? And so what we're going to do is we're going to graph those. Okay? And show that they are rigid. Let me get some graphics. Will you be doing okay today? Great. You know, one thing that I've learned in my long life, Ashley, all about perspective. You want me to explain that? She's like, no, I don't. Quit talking. Just do geometry. No, it's all about perspective. We don't have to do geometry. We get to do geometry. See the difference? We don't have to go to golf practice after school. We get to go to golf. We don't have to, I got to go to volleyball. You get to go to volleyball. You see the difference? We don't have to do geometry. We get to do geometry. There's a lot of people in the world that wish they were sitting in your seat. Right, Lance? Oh, there's a lot more behind that I could talk about. But that is true stuff. All right, let's graph this. We get to graph this. We don't have to graph this. We get to. So lucky. All right, so I'm going to graph these coordinates fairly quickly, so stay with me here. We're trying to determine whether or not it's rigid, a rigid transformation. So -3, -1. I'm doing P this side first. -3, -1. -3, -1. There's P. Q, 3, -1. R, 1, -4. There's the original triangle. And now we're going to go to the prime triangle. Let's use a different color. We'll go -3, +1. There's P prime. Let's go +3, +1. There's Q prime. And let's go 1, 4. And there is R prime. Can everyone see how there is a reflection across the x-axis? Good? All right, now if we just count 1, 2, 3, 4, 5, 6, it's 6 units from there to there. 1, 2, 3, 4, 5, 6, it's 6 units from there to there. I mean, this is rigid. The only way that it's not rigid is if you multiply by a constant. It's the only time it's not rigid. Okay? Or a fraction. Multiply by a. We good? We're going to keep moving. Kayla, any luck? Okay, I'll have to reset it at the end of class, okay? All right, let's turn over to page 35 and let's do number 5. So, page 35, number 5. Page 35, number 5. I'm going to focus this in just a little bit. There we go. All right, so we've got pre-image again and image over here. And our terms are D, E, and F, our coordinates, D, E, and F. Henshaw, can you read off the coordinates for D, E, and F for me? What's D? -4, 4, and E? And F? -4, 1. Okay, those map to D prime, E prime, F prime. Henshaw, keep going. What's D prime? Thank you. F prime. I mean E prime. I'm sorry. E prime. -2, -4. And F prime. 4, -1. All right, good. There it is. Now, what we got to do is find the pattern. Find the pattern. Don't look at both of them. Don't look at the x and y at the same time. Just look at the x's. Okay, so if I'm comparing the pre-image to the image, can you find a pattern? What, Margaret, you got a pattern?
Yeah, the switch between if they were negative, they go positive. If they're positive, they go negative.
Let's try it. Let's look at the x, which means he's saying switch, or we take the opposite. Mathematically, I got Raven finally to admit that means we multiply by -1. Right? Let's try that. What's -4 times -1? +4. What's 2 times -1? -2. What's -4 times -1? You see that? So yeah, we multiply by -1. Let's write the rule, mapping rule. And he is exactly right. Multiply by -1 for the x. Okay, let's go ahead and do the y. What do you think? Anybody? What do you think, Ashley?
Multiplying the y by
Exactly right. By -1.
-1.
4 times -1, -4. 4, 1. Very good, Ashley. Okay. What is happening when you multiply by -x, -y? What's happening transformation-wise? I mean, up here we showed that this was a reflection, right? The one before. What's happening here? It is? Over the origin. Okay, you are close. You know what? Let's do this. Before we answer that question, we'll come back to it. Before we answer it, let's graph it and see if we can look at it a little bit better. Okay? So we're going to graph this. We don't have to graph. We get the graph. Kayla? -4, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's D. E is 2, 4. 2, 4. And F is -4, 1. Man, what a fun class. We get to do graphs. Yay. Okay, D prime is 4, -4. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, D prime. E prime is -2, -4. Okay, E prime. And F is 4, -1. Okay, F prime. What in the world? Now he said, Henshaw tried to somehow say that this is a reflection across. No, not quite. It's not a bad thought. We will have a reflection across this line. Back to your Algebra 1 days, y equals x. We will have a reflection, but that's not it. It is a rotation. How much? 180 degrees. That works. A rotation, but there's another one too. A rotation of 180 degrees. Does it go clockwise or counterclockwise? Does not matter when it goes 180 degrees. Does it matter which way it goes? Does not matter because it's going to end up opposite on the other side. Okay? But there's another way to describe this. Do you guys remember yesterday we multiplied by, well, on this one, what did we multiply by? -y? And we had a reflection, didn't we? Well, all this is a double reflection. It's a double reflection. Imagination, clean the board. Double reflection. Cross. Okay? Let's try it. And look, I'm going to give you the halfway point. Let's say that we did D double prime. Watch this. This isn't even in the book. This is extra. This is extra. This is free. Doesn't cost you anything. It's free. Here we go. D double prime. -4, we're going to make that 4 because we'll multiply it by -1, and the y stays the same. So E double prime is -2, 4. And F double prime is 4, 1. Okay, so this is kind of like we just multiplied the x by -1. Let's graph it. Use a different color. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's D. -2, 4. -2, 4. There's E. And 4, 1. 4, 1, and there's F. You guys see now between blue and red how that's a reflection across the y-axis? Now between red and black, that's a reflection across the x-axis. Can you see that? It's a double reflection. So a double reflection is the same thing as a 180-degree rotation. Whew, confusing. But they are, always. Okay? Okay, let's keep moving. That was number 5. Let's do number 6. I don't think I have room on this paper, so I'm going to go to a new sheet. Number 6. Amira, can you read off? This is number 6, still on page 35. Can you read off the coordinates for the pre-image and image when I'm ready? We'll go S, T, U. Put that up here at the top for our people that are watching the recording. Okay, go.
-3, 4.
-3, 4. Thank you. T?
2, 4.
2, 4. Okay, U?
-2, 0.
-2, 0. Thank you. And then that maps to the image
-2, 2.
S prime. What'd you say it was?
-2, 2.
-2, 2. T prime
3, 2.
and U prime.
-1,
-1, -2. Okay. What's our first thing? What am I getting ready to write down? What have we done in the last 2 problems? Find the pattern. Find the pattern. Okay, so if our rule is x, y, map 2, what do you guys see as the pattern for the x's? Look closely. How are the x's related? What's the pattern? Amira? +1. Let's try it. Do we just add 1 to the pre-image? What's -3 plus 1? -2. What's -2? Or what's 2 plus 1? 3. And what's -2 plus 1? I would agree. Good job, Amira. So we found the pattern for the x. What's the pattern for the y? Try it, Henshaw. -2. Let's try it. 4 minus 2 is 2. 4 minus 2 is 2. 0 minus 2 is -2. Very good. You guys found it. There's the rule. Does that make sense? See how easy it is? Okay. All right, let's do a graph. I have, yeah, I can do the back here. All right, let's do a graph. -3, 4, 1, 2, 3, 1, 2, 3, 4. That is S. T is 2, 4, 2, 4. That is T. And U is -2, 0. And that is U. S, T, U. All right. The image is negative. Let's do a different color just because we can. What color should we use? Ooh, this orange or yellow looks good. I wonder if you can see it. Let's try it. S prime is -2, 2, -2, 2. Oh, I'm not sure. Can you see that? S prime? Oh, that is awful. I might just throw that in the trash. That is awful. No good. All right, let's go to pink. Oh, there we go. We can see that. -2, 2. Then we got 3, 2. 1, 2, 3, 2. And that is T prime. And then we've got -1, -2, and that is U prime. Let's connect. That's not great, but it's better than the yellow. Ugh. All right, so did it move 1 unit to the right and 2 units down? Let's check. Over 1, down 2. Yep. Over 1, down 2. Yep. Over 1, down 2. Yes, sir. Everyone see the rule? Okay, so this was a translation. Not a rotation, not a reflection, not a dilation. This is a translation. Okay, we good? Let's move on. Go to example B on the next page, 36. Page 36, example B. All right, so once again, pre-image, image, and we've got M, N, and P. Okay. Lance, what's the coordinates for M? 30, page 36, example B. See, I have it written right here, bud.
Oh, I can see that. Okay. For M,
Yeah.
-2, 2.
-2, 2. Okay, and what about for N?
4, 0.
And what about for P?
-2,
All right, they map to our image, which is M prime, N prime, and P prime. What is our M prime ordered pair? Thank you. And our N prime. And our P prime. -4, -1. What are we trying to find first? Find the pattern. Thank you, Amira. Find the pattern. Let's look at the x's. Is there a pattern? Did anybody see a pattern between -2 and -4? What do you think, William? Multiply by 2. Let's try it. What's -2 times 2? -4. What's 4 times 2? 8. What's -2 times 2 again? -4. I would agree. Good job, William. So xy maps to 2x. We get to do geometry. What about the y's? Anybody see a pattern with the y's? Anybody? Anybody? It's like Ferris Bueller's Day Off. Bueller. Bueller. Anybody? And Sean. Yes, but I'd rather say it like we're multiplying by 1/2. Same thing though. 2 times 1/2 is 1. 0 times anything is 0. -2 times 1/2 is -1. Very good. So 1/2 y. Do we even have to graph this? No, not at all. So even when it says confirm that it's rigid, as long as you know that on this one it is rigid, would this one be rigid since we're multiplying? Non-rigid. Yeah. If you're multiplying by a constant, remember that's when we horizontally stretch or shrink or vertically, remember that? Then it's not rigid. As long as it keeps the same orientation and shape, then it's rigid. So like if there's a 90-degree angle over here and it rotates and there's still a 90-degree angle, it's rigid. The only time it loses its rigidity is when you multiply. Okay? When you stretch it. Does that make sense? Now, what if you multiply by 1? Is that going to change anything? No. But it's got to be by a factor. Okay? Okay. So it's not a rigid motion. Any questions? All right, we're good. Let me put the homework on here. Starts on page 38. Make sure you write it down because I'm going to change the screen here in just a second. Page 38, 1 through 6. Then some selected problems. 8, 10, 11, 14, 15. We have a total of 7, 8, 9, 10, 11 problems. We get to do 11 problems. Yes. You guys are going home. Ashley's not doing this because your parents know me, but everybody else is like, my geometry teacher's crazy. All right, everyone got it written down, so I'm going to stop the recording and upload this to Canvas. We good?